Alright Chieftains, how we doing today? Thanks for logging on and watching this quick video. I'm calling it Strive for the 5 video series, guaranteed to raise your AP scores, hopefully. I got this board back here where I wrote down a bunch of math examples using the metric system, such as meters, grams, and kilowatts and watts. I realize you can't see it from where you're watching right now, so what I'm going to do is go behind the camera and narrate you through what I wrote down on both sides of this board. It should take us about 10 minutes to go through everything. And remember, you could always reference this video link if you're having trouble with some of the math in this course. Keep in mind, right, no calculators are allowed on the exams in my class or on the actual AP exam. The good thing is it's basically working with numbers such as 10, hundreds, thousands, 10,000s, millions, and billions. So if we could get a little practice understanding what we can do with those zeros, you're going to realize that the math is not that difficult, and you should be able to handle it without any problems. Alright, so let's take a look through this board. Alright folks, here we are taking a closer look at the board. First thing I want to say is excuse my penmanship. It's not ideal, but it is legible. Some information you should know in this class. 1 meter is the base unit, meaning your answers should be reported in meters. Just so you remember from your earlier math classes, 100 centimeters is the same as 1 meter. Also, 1,000 millimeters is equivalent to 1 meter. As we roll down to kilograms, okay? Kilogram is the base unit, right? Your answers will typically require you to report the final result in kilograms. Just so you know, 1,000 grams equals 1 kilogram. So therefore, 100 grams is the 10th of a kilogram, or 0.10 kilograms. We'll come back to that one. Watts and kilowatts, which refers to electricity, right? 1,000 watts is equivalent to 1 kilowatt. 1,000 kilowatts is equivalent to 1 megawatt, which is MW. Therefore, 1 megawatt is equivalent to 1,000 kilowatts, or 1 million watts of electricity. Kilowatts is typically the base unit, which your answers will require as a final result, but sometimes you will see megawatts, right? So keep in mind, a megawatt is 1,000 kilowatts. Therefore, it's 1 million watts, right? Like I said earlier in the intro, all it is you're adding zeros and taking away zeros in this course. No calculator required. All right, so let's take a look over here and we'll see a more typical style AP problem. All right, so let's take a look at a little surface area issue. We have a parking lot that is 100 meters by 100 meters. Remember, surface area is length times width, okay? So the total surface area of the parking lot, all right, is 10,000 meters squared. 100 times 100 is 10,000. 1 add 4 zeros gives you 10,000 meter squares. Now this is where the AP folks like to get tricky. All right, and they're going to say annually the parking lot receives 200 millimeters of rainfall. Calculate the total volume of precipitation in meters. Right? That's tricky. Your surface area is in meters, your rainfall is in millimeters. Okay? So you remember your volume is your length times width times height, right? The rainfall in millimeters will give us the height for this problem. So basically you have 100 meters times 100 meters times 200 millimeters. Why is there a problem, right? Think about it. You cannot multiply meters, meters, and millimeters. All your units have to be the same. But with a little metric knowledge, we could work this out and find the solution in no problem. Alright folks, so we already went through one half of the lesson, right? Pretty quick and not so difficult. All you got to do is remember your metric units. 1,000 grams equals 1 kilogram. 1,000 millimeters equals 1 meter. 1,000 watts equals 1 kilowatt. Therefore, 1,000 kilowatts equals 1 megawatt. Right, so we had that little problem where you had meters, meters, millimeters. I'm going to show you how to do the conversion or the dimensional analysis, as some people like to refer to it. And then basically you're going to be able to do this math problem real quick. And then I have a few other examples up here dealing with conversions, right? So you have grams of something and you have to report it in kilograms, or you have watts of electricity and it has to be reported in kilowatts and stuff like that. So let's take a look at this. Lesson's done, video's over, but remember, you're going to have an assessment, right, in class on this stuff. So make sure you're paying attention. You could take notes, and you could also reference the video at any time. All right, so let's get to the other half. All right, Chieftains, so here we are back to the parking lot problem of meters, and millimeters. Remember, right, so this is where some metric knowledge pays off. 1,000 millimeters is equivalent to 1 meter. So all we have to do is divide, right, millimeters by millimeters to convert 200 millimeters to meters, right? So if we look at this down here, right, 200 millimeters divided by 1,000 millimeters. You'll always do that, gives you 0.2 meters, okay? So we don't have a calculator, don't panic. All you have to do is, because you're dividing by 1,000, is shift your decimal spot 3 spaces to the left, and it will also give you 0.2 meters, right? So starting from the end of 200, move your decimal 3 spots to the left, gives you 0.2 meters. Now we're golden. We can finish the problem. All right, 100 meters times 100 meters times 0.2 meters. All right, we don't have a calculator. We got to scratch it out the old way. So I'm going to take 10,000 meters times 0.2. Right? If I do this the old way, I end up with 20,000. But because I have a decimal, right, I have to move it 1 spot to the left, and I end up with 2,000 cubic meters, all right, the volume of precipitation, right? So let's go back through that quickly one more time. 100 times 100 times 0.2. All our meters are the same, right? The meters, meaning the units, right, will give us 2,000 cubic meters of precipitation. All right, folks, let's take a look at a problem that requires grams to kilograms, okay? Let's assume 1 gallon of gasoline, while burned, will emit 10,000 grams of carbon dioxide. All right, imagine there's a lawnmower with a 4-gallon tank. Every time the lawn gets mowed, 4 gallons of gasoline will be consumed, right? So based on that information, we could assume, right, 4 times 10,000 is going to give us 40,000 grams of carbon dioxide that this lawnmower emits during each mowing. All right, but the AP people are going to say, hey, what's the total CO2 emitted in kilograms? Okay, so we have a little problem here. We have to do a conversion, right? Remember, okay, 1,000 grams is equivalent, all right, to 1 kilogram. So if we take 40,000 grams, divide it by 1,000 grams, move your decimal 3 to the left because you're dividing by 1,000, you will end up with 40 kilograms of carbon dioxide. All right, so moving down, let's take a look at a little problem regarding light bulbs. Okay, excuse the light bulb reflection on the board. Here, we have a 60-watt light bulb that is used 5 hours a day. Based on that information, we could assume this one light bulb will consume 300 watts of electricity per day or daily. All of a sudden, the AP people say, hey, calculate the total kilowatts a year, okay? Started off in watts, now you need the annual kilowatt consumption, right? So here we have 300 watts times 365 days gives us 109,500 watts per year, right? You're going to have to write that out the old mathematical way, right? Using a pencil and a piece of paper, 300 times 365. So what I recommend you do is you stop the video, you do the scratch math right now to make sure you can make sure your numbers are all lined up and you're getting the same answer as I am. Okay, welcome back. Hopefully you got the correct answer, right? Remember, we need this in kilowatts, right? As below, 1,000 watts is the same as 1 kilowatt. No calculator required, right? So all you do is you shift your decimal over to the left or to the right. You got it, to the left, right? 3 to the left. 109.5 kilowatts per year is what this one light bulb will use if left on for 5 hours a day. All right, Chieftains, great job. You can see the math isn't that overwhelming at all. Good luck on your assessment and keep referencing this video series. All right, Chieftains, that was our first Strive of the 5 video series. If you had some problems with the video, please go back, watch it again. Remember, take notes. If you're still having some problems, come see me anytime after school. I'll be happy to sit down with you and help you out. Good luck on your assessment, and I look forward to having this discussion with you. Take care, guys.